Howdy algebra students, it's time for another online lesson. Today we're looking at lesson 12.5, rational expressions with like denominators. I think this lesson will go pretty quickly and you'll be able to catch on to it really well. Well, up to this point we've looked at rational expressions and we've done some multiplying and dividing of them. And so now it's time to start moving on to the next operation, and that is to add them. And of course, as you all know, when we add fractions, we need something called common denominators. That's probably one of the first things that has been drilled into you when you've studied about fractions. And so it's no different here. Same type of thing, common denominators. The only difference now, when we have rational expressions, that these denominators will no longer be just numbers, but now they'll be variables. All right, let's look at a couple examples here right away. So the very first one, now notice that this one does have common denominators right away. X over 7b plus 3x over 7b, so there are common denominators right away. So we do not add those. All we have to do is add my numerators. So remember, there's a 1 in front of here, so 1x plus 3x is 4x, and your denominators, remember, stay the same. So 4x over 7b is the answer. We look for ways to reduce these, but we can't do any reducing of the numbers or the variables, so we're done. So that was pretty easy. Let's look at the next one. Now the next one, again, do we have common denominators? Yes, we do. The b plus 5 is the same in each case, and so then we can just combine them essentially. The b plus 5 stays in the denominator, and with my numerators then it just becomes 4 minus b. Now, can I do any reducing here? Could I perhaps cancel out these b's? Well, as you know, I cannot, because the b's are added and subtracted. I can only cancel or reduce when I'm multiplying or dividing. So far so good. A couple other ones. Now, these two are a little trickier, but I think you'll be able to catch on to these also in pretty good shape. Now, we have a common denominator in the first one. It's this r minus s. So far so good. Once again, all we're going to do is that r minus s is going to be my denominator. I'll just write that down. And then I can try to combine my numerators. It is going to be just r minus s. Now, can I do any reducing on this one? Well, I can, because even though there doesn't appear to be any multiplying or dividing, because the same expression, the same binomial is over itself, I can indeed go ahead and cancel these out like that. And so my final answer then is actually, is it 0 or 1? Yep, you guys know that it should be 1. Same value divided by itself always equals 1. Alright, let's take a look at this next one here. This one's kind of a sneaky one, because at first glance it might seem like that there are not common denominators here. N minus 3 and 3 minus n. They're close. There is a 3, there is a n, but they don't seem to be common. However, the tricky part here is recognizing that if I multiply this second fraction, let's say, by negative 1 over negative 1. Now, why would I want to do that? Well, we'll see in a little bit. Remember, this is not changing the value of anything. When I multiply by some number over itself, it's like multiplying by 1, so that should be fine. Let's see what I end up with here. Well, I can say that 9 times negative 1 is negative 9. Now, here's the key part right here. When I multiply this negative 1 times 3 minus n, it is like the distributive property. So negative 1 times 3 is negative 3, and negative 1 times negative n is plus n. So now I have this problem, n minus 1 over n minus 3. Now, still doesn't right away look like I have common denominators, but remember that negative 3 plus n Sure enough, that is the same as n minus 3. So I have the negative 9 there. I still have my n minus 3 here. And so now I do have those common denominators. So now all I have to do is combine my numerators. So I do have a couple numbers I can put together here. Negative 1 and negative 9 is negative 10. So my final answer here then is n minus 10 over n minus 3. That's the best I can do. Remember, I can't do any reducing or canceling here. So that's my final answer. All right, let's look at maybe an example here. Find an expression for the perimeter of a rectangle if its width is m plus 4 and its length is m minus 1. Let's see if we can draw a little picture here which might help things out a bit. So we have a rectangle like this, and we're told that the width is m plus 4 over 5, so we could think that that would be right here. The length is m minus 1 over 5, so that could be here. So we know that perimeter means the whole distance around. So do you see that what's going to end up happening here is I'll have m plus 4 over 5 plus m minus 1 over 5, and then I'll just add those again, because with a rectangle those opposite sides are going to be the same. So I'll have another m plus 4 over 5 and another m minus 1 over 5. Now notice I have common denominators all the way around here, don't I? So I can go ahead and be assured that my common denominator will be 5. And then let's think about my numerators. Can I combine anything there? Well, I think I can, because there's a 1m and a 1m and a 1m and a 1m. So when I combine all those together, I get 4m. And here's some numbers: 4, negative 1, 4, negative 1. Well, if I add those together, 4 minus 1 is 3, 3 plus 4 is 7, 7 minus 1 is 6, and it's positive 6. So my final answer then actually becomes this 4m plus 6 over 5. So that's a quick lesson on how to add rational expressions when the denominator is the same. So thanks for taking notes and bearing with me here. We'll see all you guys in class tomorrow. Bye now.